Good day everyone, my name is Jabir Ahmed and I am presenting today on a fascinating and essential topic in food science and meat processing, the aging of meat. The process of aging meat transforms a raw agricultural product into a tender, flavorful and premium culinary experience. Over the next 10 minutes, we will undertake a comprehensive analysis of the biochemical mechanism that drive the change, explore the two primary methods used, dry and wet aging, and discuss the critical control factor necessary to ensure both quality and safety. To start, what exactly it means aging? It is often misunderstood, but simply put, it is a carefully controlled postmortem biochemical process. The slide summarizes it as a controlled decomposition. Instead of allowing the meat to spoil, we store it under precise temperature and humidity condition to let naturally occurring enzyme in the muscle tissue break down the muscle structure. The process serves a dual indispensable purpose. First, to increase tenderness, which is about improving the texture and making the meat easier to chew. And second, to develop flavor, which enhance the taste profile, making it richer, more complex, and far more desirable than fresh meat. Let's take a brief look at the postmortem timeline of muscle tissue. The process begins immediately after slaughter. When the animal is humanly harvested, circulation stops and the muscle cells shift to anaerobic metabolism. Within hour, we enter the rigor mortis, a phase where the muscle fiber contract and become stiff. This occurs because the primary energy source, ATP, is depleted, leaving the actin and myosin filament locked together. This is why meat must never be consumed immediately after slaughter. It is at its toughest point. The third stage is the resolution of rigor mortis. This is where the magic begins. Naturally occurring enzymes start to attack the structural component. This initial softening is crucial. Finally, we have the formal aging period, an extended phase where we allow the enzymatic process to run their course for days or even weeks to maximize tenderness and flavor development. Let's delve into the core science starting with tenderness, which is primarily achieved through proteolysis, the breakdown of protein. The key player here are the calpain enzyme. These are calcium dependent enzyme already present in the muscles. Once the animal is deceased, calcium is released, activating the calpain. The calpains begin systematically targeting and degrading key structural proteins. These proteins include desmin, which link myofibrils together, and titins. The most important area is the jet disc, which acts as the anchor point for the muscle fiber. The result is the fragmentation of the myofibrils, which weakens the entire muscle structure. This reduction in structural integrity is physically felt as increased tenderness when we chew the meat. While proteolysis handles texture, flavor is a more complex outcome involving two main processes, lipolysis and oxidation. Lipolysis is the breakdown of intramuscular fat or marbling into free fatty acids. These fatty acids are volatile, meaning they become aromatic and contribute significantly to the savory smell and taste. Simultaneously, the breakdown of structural protein yields small peptide and free amino acid. One of the most important is glutamate, which dramatically enhances the umami, the savory, brothy taste that we associate with aged meat. This biochemical complexity leads to the development of those highly sought after nutty, earthy, and buttery notes, which are most pronounced in the dry aging process. Now let's compare the two methods, beginning with dry aging, the traditional and arguable most artisanal method. In dry aging, primal cuts of meats are hung naked in a specialized humidity controlled environment, exposed to open air. The conditions are strictly maintained, typically 0 to 4 degrees centigrade with 80 to 85% humidity. The exposure to air allows for significant moisture evaporation, which is the key driver of concentrated flavor. This evaporation forms a hard, dark outer crust or bark. This bark must be trimmed off before consumption, which is a major factor contributing to yield loss. However, the reward is worth the loss. The flavor profile is intense, often described as heavy nutty, deep beef notes, and sometimes subtle blue cheese undertone. The process usually takes a minimum of 28 days but can extend to 45 days or more. In contrast, wet aging is the modern standard. dominating the commercially meat industry due to its efficiency. The process involved placing the meat immediately into a vacuum-sealed airtight plastic bag. The meat is then allowed to age in its own juice, often during shipping and transportation. Because the meat is sealed, there is no moisture loss, resulting in a significantly higher yield and thus higher profitability for processors. However, the flavor profile is different. The anaerobic environment traps muscle fluid, including lactic acid. This can lead to a slightly metallic, sour, or sometimes bloody taste when the bag is first opened. When, while it still achieves tenderization, the intense complex flavor of dry aging are largely absent. The speed is much faster, typically taking only 14 to 21 days. This table summarizes the core difference between the two methods. Dry aging is defined by its open-air environment, leading to intense nutty flavor and a high yield loss. It's a premium product. Wet aging uses a vacuum-sealed environment, resulting in a milder, more acidic flavor, a low yield loss, and is the standard commercial product. Both methods succeed in tenderizing the meat, but they deliver drastically different flavor experiences. The economics are clearly visualized here in the yield analysis. Yield is critical because it dictates the final cost of the consumable product. Weight hedging has an outstanding yield, typically retaining around 98% of the original weight. This makes it the dominant method for mass production. Dry aging, however, suffers a substantial loss. It retains only about 80% of the original weight. This 15 to 20% loss is due to two factors. First, water evaporation, and second, the necessity of trimming the thick, dried outer crust. This high loss contributes directly to the higher piece of dried aged steak. Regardless of the method used, mastering four critical control factors is essential to prevent spoilage and ensure quality. First, temperature must be maintained between 0 to 4 degrees centigrade. If the temperature is too warm, you risk rapid bacterial spoilage. If it's too cold, the enzymes stop working. Second, humidity is critical, especially for dry aging, usually set between 80 to 85%. Low humidity dries the meat out too quickly. High humidity encourages dangerous mold growth. Third, airflow is vital, particularly for dry aging. Acid removes moisture and maintains a dry surface, which inhibits bacterial growth. Finally, time governs the final result. While tenderness is achieved quickly, flavor intensity grows with time, peaking typically between 45 to 60 days. Food safety is paramount in meat aging. We must differentiate between harmful and beneficial microbial activity. Spoilage bacteria such as Pseudomonas are aerobic organisms that thrive on meat surface, causing slime, off odor, and necessitating expensive trimming. Control is achieved by keeping temperature low and maintaining a dry surface. Conversely, some beneficial microbes like certain species of mold such as Thamnidium can form on the dry edge crust. These mold are harmless and they can actually release enzymes that penetrate the meat, and enhancing flavor notes in a manner similar to cheese making. The critical factor is ensuring they are trimmed away before cooking. In conclusion, meat aging is more than just storage. It is a sophisticated, time-dependent, and highly controlled application of food biochemistry. It's a balance between science and craft. Proteolysis drives the tenderization process, while lipolysis and oxidation create the characteristic flavor profile. The choice between wet aging, which prioritizes yield and efficiency, and dry aging, which prioritizes intense premium flavor, depends entirely on the market and the desired product outcome. Thank you for your attention. I hope this detailed overview has provided a clear understanding of why and how we age meat, transforming it from a muscle to a masterpiece.